The next wave of AI after that is called physical AI. And this is really, really quite extraordinary. This is where we're going to need 3 computers. One computer to create the AI, another computer to simulate the AI, both using for synthetic data generation, as well as a place where the AI robot, the humanoid robot or the manipulation robot, could go learn how to refine its AI. And then, of course, the third AI is the computer that actually runs the AI. So it's a three computer problem. You know, it's a 3-body problem. And so it's incredibly complicated, and we created 3 computers to do that. And we made a video for you to enjoy understanding this. The thing that we've done here is this. Each one of these computers, depending on whether you want to use the software stack, the algorithms on top, or just the computing infrastructure, just the processor for the robot, or the functional safety operating system that runs on top of it, or the AI and computer vision models that run on top of that, or just the computer itself. Any layer of that stack is open for robotics developers. We created a quick video. Let's take a look at that. Is that okay?
That sounds great.
The era of physical AI is here. Physical AI, models that can understand and interact with the physical world, will embody robots. Many will be humanoid robots. Developing these advanced robots is complex, requiring vast amounts of data and workload orchestration across diverse computing infrastructures. NVIDIA is working to simplify and accelerate developer workflows with 3 computing platforms: NVIDIA AI, Omniverse, and Jetson Thor, plus generative AI-enabled developer tools. To accelerate Project GR00T, a general humanoid robot foundation model, NVIDIA researchers capture human demonstrations, seeing the robot's hands in spatial overlay over the physical world. They then use RoboCasa, a generative simulation framework integrated into NVIDIA Isaac Lab to produce a massive number of environments and layouts. They increase their data size using MimicGen NIM, which helps them generate large-scale synthetic motion datasets based on the small number of original captures. They train the GR00T model on NVIDIA DGX Cloud with the combined real and synthetic datasets. Next, they perform software-in-the-loop testing in Isaac Sim in the cloud and hardware-in-the-loop validation on Jetson Thor before deploying the improved model to the real robots. NVIDIA Osmo Robotics Cloud Compute Orchestration Service manages job assignment and scaling across distributed resources throughout the workflow. Together, these computing platforms are empowering developers worldwide to bring us into the age of physical AI-powered humanoid robots.